Welcome to a video on quadratic regression using Desmos. In this video, we'll use a quadratic regression model to describe how weight affects relative fitness. Then we'll use our model to make predictions. Let's get started. All of the graphs used in this video are linked in the video description below. Please feel free to follow along using the graphs linked below. Here's our problem statement. The following table shows the weight in kilograms of several randomly sampled animals of a particular species and their corresponding relative fitness. On the left side of this table, we have the weight in kilograms. These values are ranging from 4.3 kilograms to 16.5 kilograms. And the relative fitness is a 4-digit decimal number. Let's use a graphing tool to perform a quadratic regression to find a quadratic equation that best fits the data. Let's go through the steps on how to create a quadratic regression model using Desmos. Stay to the end of this video for step-by-step instructions. I've included a link to the data in the video description below. The first thing we need to do is to copy our data into a table on Desmos. So let's go ahead and select all of the data values in our table and copy them using either Control-C or Command-C if you're on a Mac. Now let's go over to the Desmos website. Navigate to desmos.com, then from the Math Tools window, select Graphing Calculator. This should open a blank graph. To insert our data, there are two ways to do this. From the upper left-hand side, you could click plus and then select table. This would allow you to type in the data manually. Or you could also just paste your data into the first cell on the left-hand side using Control-V or Command-V. When I copied the data, it inserted it into a list, but I actually wanted to use a table instead. Since this often happens to students, I want to show you how you can work around this problem and not have to enter your data in manually. Let's go ahead and close this. And what I'm going to do is I'm going to open a spreadsheet like Google Sheets or Microsoft Excel. And I'm actually going to paste my data into the spreadsheet. Once you've pasted the data in, go ahead and reselect it from your spreadsheet and select Copy, either Control-C or Command-C if you're working on a Mac. Go back over to Desmos, click in the first cell on the left-hand side, and either hit Control-V or Command-V to paste the data. And now you can see that my data has appeared in a table. This is a way that you can copy and paste the data without having to insert it manually. I want to make the scatter plot a little bit easier to see on this video. So I'm going to go over to the 4 dots by Y1. And I'm just going to press and hold on that. And I'm going to change the size of the points to 16. That'll make the dots a little bit easier to see. I'm going to go over to the graph settings on the upper right-hand side, and I'm going to change the settings for the X and Y axis to make it a little bit easier for us to see. I'm going to change the X axis to have a range between -1 and 20, and the Y axis to have a range between -0.1 and 0.9. Now that we're looking at the graph, we can see that this does have a round shape as opposed to a linear shape. So a quadratic equation might be a good fit for this data set. To perform the quadratic regression, go over to the left-hand side, just to the left of your table. You'll see a slash with 2 dots on each side. If you hover the cursor over that button, it should say Add Regression. Let's click on that button to add a regression to this model. Desmos will default to a linear regression, and clearly a linear regression does not fit this data. Let's choose quadratic regression from the pull-down menu. Just below that pull-down menu, you should see the equation of our quadratic regression function. You can add this equation to a cell in the table by clicking the button to export this to our expression list. You'll see I now have the equation inserted into a new line on the left-hand side. So our equation is y equals negative 0.00443958x squared plus 0.0955846x plus 0.206553. Now, if this is a question on My Open Math where you need to insert the coefficients, you can highlight the values of those coefficients and you can copy and paste them directly into My Open Math. Pay attention to the directions because you may need to round those values to 4 decimal places. It will depend on the question that you're working on. Okay, so now let's go ahead and use the model that compares relative fitness by weight in kilograms. Let's use the model to predict the relative fitness of an animal weighing 5.2 kilograms. Let's round our answer to 4 decimal places. So since we want to predict the relative fitness, we're looking for a Y value for an animal weighing 5.2 kilograms. The weight were our X values. So essentially, this problem is asking me to find Y when X is 5.2. So if I wanted to do that, I would just plug 5.2 in for X. So Y would equal negative 0.00443958 times the quantity 5.2 squared plus 0.0955846 times 5.2 plus 0.206553. Okay, that's a mouthful. All we need to do is to use our calculator to evaluate this. But let me show you how you can use Desmos to do a lot of the heavy lifting for you. Let's go back to Desmos. Here we are in Desmos, and remember, we added our equation to a new cell on the left-hand side. And although that says y equals, I'm going to go over and I'm going to change y to f of x because that's a function and I want to be able to evaluate the function when x is 5.2. So I want to find f of 5.2. And look at that, we get 0.5835 rounded to 4 decimal places. So we found that y was 0.5835 rounding to 4 decimal places. And so this is the predicted relative fitness of an animal weighing 5.2 kilograms. Now let's take a look at another problem. Based on our model, what weight produces the optimal relative fitness for this species? Around to 2 decimal places. So the key word here is optimal relative fitness. The optimal value of a quadratic equation always occurs at the vertex. So to find the optimal relative fitness value, we're going to need to find the vertex. Let's go back over to Desmos and use it to find the vertex of this quadratic equation. To find the vertex of our model, hold your cursor close to that optimal or highest point on the parabola. It should appear as a coordinate pair. In fact, you can click the button to export the point to the expression list. So there is the vertex when x is 10.76505 and y is 0.721039. Once again, we found our vertex was the point 10.76505, comma 0.721039. Now let's use that to answer this question. The weight that produces the optimal relative fitness is going to be the x-coordinate of the vertex. So rounding that to 2 decimal places, that would be 10.77 kilograms. A commonly asked follow-up question would be, what is the optimal relative fitness? In that case, it's looking for the y-coordinate of the vertex, which would be 0.7210. Let's summarize how to perform quadratic regression using Desmos. The first step is to enter the data into the table in Desmos. Second, you want to click on the button just to the left of the table to add regression to the graph. Then third, you want to select quadratic regression from the pull-down menu. Then click on the button to export the equation to the expression list. Then use your model to make predictions. That's it for this video. Thanks for watching.